Hi everyone, welcome to the final PowerPoint quarter for math. And for this final quarter, we'll be talking about ratio and proportions. Let's go. Okay, thanks, Paul. So, what are ratios? Ratios are a way we compare two values. Now, unlike fractions, which has one number be part of the other, we instead use two whole numbers. For this final quarter, we'll be talking about them as well as proportions. But just in case, here's an example. Let's say you're making a fruit juice and you wanted to see the connection between pineapple and mango. In this case, you'd write it as pineapple to mango, which represents the ratio of how much pineapple to mango was inside your fruit juice. Now, how do we present ratios? There are three ways to do it. Either do it A to B, like butterflies to flowers, A with a A and B with a colon in the middle, like beds to people, or you write a slash in between them, like you would when writing a fraction on a computer. Also, to your right, you'll also see examples, real-life examples of these. Now, how do we apply ratio in real life? Well, let's say, for example, you were working at a factory that made automobiles, and your boss one day told you to check how many trains were being made at the same time as cars. When you were checking, you realized, hey, every time two trains are made, 5 cars are made at the same time. In ratio, it's written as 2 to 5. Second one's shorter, as it has 2 men trying to run in a marathon. One can cover 5 kilometers, while the other covers 7. The ratio of distance traveled by both is 5 to 7. And then the final one is my personal favorite. At your local arcade, there's a game called Whack-A-Mole, and as you start playing it, you realize that every time you whack 3 moles, 3 more moles would pop out. In ratio form, it's written the number of moles that appear after some are whacked is 1 to 1. Wait, why is this 1 to 1 and not 3 to 3? Well, that's because some parts of ratio are similar to that in fractions. In this case, you have to simplify them, just like in fractions. Now, how do we simplify them? It's simple. Just like in fractions, you must find the greatest common factor of both numbers on both sides into the ratio in order to divide and simplify them. 2 to 6 has 2, which makes them 1 to 3. 16 to 72 has 8, which makes it 2 to 9. And 200 to 100 has 100, which makes it 2 to 1. Now let's talk about proportions. They're somewhat similar to ratios in comparison, but instead of comparing two numbers, they compare two ratios. Proportions are used to ensure that both ratios are equal, and you'll normally know if two ratios are proportional if both have the same simplified form. For example, let's say you had fruit drinks. One is 1 liter with 200 grams of pineapple and 150 grams of mango, and another has double the amount of mango and pineapple as the first. When simplified, both ratios give you the same thing, 4 to 3, which makes them proportional due to the equivalent ratio. Now, let's say you were asked to solve problems in ratio. These examples will show you how. So imagine if your car gets 30 miles every time it gets fed 1 gallon, how many gallons of gas do you need to commute to your school every day if your school is 5 miles? First, you gotta get your two ratios. The first one should be the miles to gallons, in this case 30 miles to 1 gallon, and the second should be 5 miles to an unknown amount of gallons, which we'll just put X there for now. After you make your two ratios, transform the ratios into fractions with the miles going on top and the gallons at the middle. After making both ratios fractions, and cross-multiply them. And once you're done cross-multiplying, you'll find yourself with a solve for X situation. You should divide both sides by the number that's with the variable, and you should get your answer. And sir, as you can see to the right here, we start with ratios, then we turn them to fractions, cross-multiply, we get a solve for X problem, and then you remove the 30 by X by dividing both sides by 30, which gives us 1/6. Now here's another example. Well, let's say a recipe needs 3 eggs to make 5 hotcakes. If Joseph was asked to make 20, how many eggs does he need? He'd first express the ratio. First, create the ratios 5 to 3 and 20 to X if you want. And then turn both of them into fractions with the number of hotcakes going on top and the number of eggs going at the bottom. When you do this, you should be able to cross multiply them, and when you do, you get 5 if x equals 60. Divide both sides by 5 to get rid of 5 on the left side with the variable, and when you divide 60 by 5, you get 12, giving you how many eggs you need. Now, let's try solving these proportions. Okay. So, question number 1. Miss Reyes needs to type a 420-page manuscript. She can type 15 pages in 2.5 hours. If that's the case, how many hours does it take? Can she finish typing that manuscript? So, first, let's write our ratios. So, we know she can finish 15p, always at the units. That's every 2.5 hours, or ORS for short. Which is, in this equation, equal to, 420p, or pages, to an unknown amount of hours. Okay, in fraction form, they should look like this, with the number of pages being on top, and the number of hours being at the bottom. So 15 over 2.5 times, you need to cross multiply here. You gotta cross multiply here, or 420 over x. After cross multiplying, you should have I wrote the division sign too early. You should have 15x is equal to, what happens when you multiply 420 by 2.5, you get 0, 0, 1 here, carry the 1 here, 0, 4, 8. You get, it's 15x on one side, and you get 1,050 on the other. Do the division, and you'll find out that once you do the division part, here's 70 here. Here, you'll find that at 1,050 divided by a 15 will give you 70, which means our answer here should be x equals 70 hours. Your answer should be 70 hours. Are we correct? Yep, we are correct. Now let's move on to the next question. This is also the last one. Wait. Here. Oops. Okay, so a survey showed that for every 3 people that preferred a certain brand, every time 3 people preferred a certain brand, 5 people preferred another. So if a total of 27 people preferred brand A, how many people preferred brand B? So our ratio here is 3A people. That should be 3A people to 5B people. The capitalized letters are used to represent the brands. Wait, make sure this looks good. Perfect. There. Okay. So, and we know that 27 people preferred brand A. So we have 27A here. No, that needs to be look good. Right here. And so does the 2. So 27 people preferred brand A, while an unknown amount preferred brand B. These are our 2 ratios, and in fraction form, they should look like this. This 3A over 5B needs to be cross-multiplied with B, or X, XB, which is underneath 27A. Okay. Once you do the cross multiplication, you should have. Okay, wait. 8, get rid of these. Okay, so you get rid of these. These. Oh, wait. You should end up with 3x is equal to 27 times 5 would give you 135 people. Oops. If, oops. Sorry, real fast. I need some help getting my notebook back. I could please? Okay, so yeah, if you multiply 27 by 5, you'll get 135, which needs to be divided by 3. The last part's simple. We just have to divide both parts by 3 to cancel the 3 in the part with the variable, and divide 135 by 3. If we do this correctly, it should give our answer, but first, I need some tech help here. Thanks tech help. Okay, so if we do this correctly, 135 divided by 3 should give us 45 B people. That's how many people chose brand and B. And that is our solution. As seen, yes, it is our solution. And with that, we have finished proportions. And thanks everyone for listening and into all my Math Quarter PowerPoints. And I thank you for this wonderful day. Bye everyone! Oops.